Hi, I'm Jake Tsioka, and I'll be explaining how to analyze Couette flow, Poiseuille flow, and a hybrid flow using Ansys-Fluent. To start, you want to open a geometry in the design modeler, and then get on your XY plane, and you're going to sketch a rectangle and add some dimensions. Then you can change your units to whatever it's specified. I'm choosing millimeters, and I'm going to edit my height to be 5 millimeters and my length to be 750. Once that's done, I'm going to come to Concepts, Surface from Sketches, choose Box Select, and apply. Once that's done, you should have a sketch fully completed and be able to mesh. To mesh, you want to go on your XY plane. Starting, you want to label each edge. To do that, you're going to press on the edge that you want, and then press N on your keyboard to name. Now that everything's named, you can come over to your mesh and insert two sizing specifications. Your first one's going to be between your top and bottom plane, and then you can change element size to number of divisions. I'm going to use 100 divisions because that's the max for the student version. And then change curvature to no, and behavior to hard. Now you're going to do the same thing but for your inlet and outlet. Your inlet and outlet, element size, number of divisions, again 100, no curvature, and hard. Once that's done, you can add a face mesh to the front surface and apply, and then change your element size on your main mesh to 0.001, and then generate your mesh. It should look all black, and once you zoom in, you should see all of the rectangles. Without the face mesh, this will all look, it'll have more curvature to it, and it'll mess up your vectors. Once all this is completed, you can update and then exit, and it should have a green check mark. Next, you can open up your setup. You want to turn on double precision, and solver processes can be 4. To start, I'm going to edit my model and make sure I have laminar flow. Then I'm going to edit my residuals from results and come to residuals, and I'm going to change this to my desired value. And then we can come to materials. To achieve laminar flow, I'm doing Couette and a Poiseuille hybrid flow. So density I'm choosing as 1, and then my viscosity is going to be 1 to the negative 4. I'm going to change and create that and close. And I'm going to make sure it's updated in my reference values. Once that is updated, we can come to our boundary condition and inlet. For the inlet velocity, I'm going to do 0.08 meters per second. And this is all meant to achieve laminar flow. These are the values needed for this specific flow. My outlet pressure, I want to change to make sure it has prevent reverse flow. Once that's applied, we can close, open up our wall. Our bottom wall should remain stationary, so we're going to double check that it's set up. Stationary wall, no slip condition. And then our top wall, we need to make sure it's moving to achieve the Couette flow portion. And for this, I'm going to choose 0.6 meters per second. Now, double checking reference values updated, we can move down to our initialization. This isn't needed for my project, but if you need it, you can get your initialization values, double check that that's working. And then if you need a plot of your residuals, or you need to run this until it converges, you can come to run calculation, make this iterations like 500 to 1,000, and you should reach your convergence. I'm going to use 150 just for the sake of time. Now it's running through all the iterations. Once that's completed, you can come So my iteration's completed. It only took 61 for the Poiseuille hybrid. You can get your residual graph. But once that's completed, your setup is done and you can open up your results tab. Once here, you can get on your XY plane. For my project, I need a midline and endline to do this. Create two lines, one being your midline. It's going to be halfway through my tube. So 750 divided by 2, 375, and make sure you get your whole height, mine being 5 millimeters. I'm going to make sure my samples is 100, and I should get a yellow line in the middle. I'm going to do the same for inline. I'm going to put this right before the end of my tube to make sure there's no errors in the calculation that it does. And again, sample size 100. So now we have two, midline and inline. Next we can add a contour. I want it to go through my symmetry 1, and your variable can be velocity u. Edit this to have more contours and apply. This may get in the way. You can edit this, come into your legend view and making it horizontal, and then now you have your contours. You can next add a profile vector or a velocity vector. Insert, again, you want it to run through your symmetry 1. You can reduce arrow sizes, because at first, if I don't update this and you get rid of your contour, your arrows will be a little bit of a mess. To change this, you can change your reduction factor and your symbol size accordingly. Once that's completed, you can move on over to your chart, create a chart, and this is where we're going to be getting our data series. You can name this for your hybrid flow profile, and we're going to import our data series of midline, choose your midline, add another for your inline, and then update your x-axis. You want this to be velocity u and your y-axis just to be y, and apply, and you should receive your profile vectors. And once that's completed, you can export, and that'll give you an Excel sheet, and you can actually find the values needed to answer some of the questions. To do the geometry and mesh is the same for all three types of flow, but I'm going to skip that part and cut to the setup of my Couette flow. I've already completed my Couette flow, but I'm going to briefly go in and show the setup. Okay, in my Couette flow, again, we updated the models, make sure it was laminar. Materials, I edited my air to be 0.9 and one of the -5, again, to make sure I keep the Reynolds number under 2300. And results, residual, again, same thing. But what is different is my boundary condition. I changed my inlet pressure, or what was originally an inlet velocity, and I edited it to be a pressure inlet. And once this loads, you can see that I prevented reverse flow for my pressure inlet. Outlet, same thing, reverse flow, but keep everything else the same. And your wall, which is part of the hybrid flow, I edited to be 5 meters per second. All these values are meant to make sure your Reynolds number is under 2300. Next, we are going to open the results tab for the Couette flow. So in my Couette flow, I've already added my midline and inlines, and contours, vectors, everything's the exact same. In adding it, it'll just appear different because of the different flow type. So for Couettes, you can see your vectors, it starts low and will slowly increase towards the top as the plate increases the velocity. This is easier to see by going to the end, and this curve should be linear for a proper Couette flow. And we can see our chart, and we can open our chart 1. Again, these should be linear if it was done properly. Next, we're going to look at our Poiseuille flow. Again, geometry and mesh will be the exact same as done in my hybrid flow, but we will take a look at the setup. And the reason my Couette flow may not be linear is because of a lack of divisions in my mesh or just user error. Okay, again, models, laminar, you want to update your residuals from the results tab, and whatever material stuff you need, then update it in your reference values or your error value. The main thing that is different is you have a velocity inlet. For me, I chose 0.04 to achieve my laminar flow, and made sure my outlet, again, it's important that you have prevent reverse flow, and make sure both your walls are stationary. Stationary wall, and the bottom wall should be stationary as well. Once you have all that done, if you need it, you can do your calculations for convergence and residuals. And I will open the results tab to show what it looks like. Once you repeat all the steps, creating your contours, midline, inline, and your velocity vectors, you should have something that somewhat looks like this with a parabolic end velocity profile, and we can see the initial profile if we come over here where it's roughly equal and slowly creates more of a curve. Your contours look something like this, and you can see your velocity profile. Both lines are here, your midline and inline. It's just that the velocity profile is fully developed by the time it reaches the midline, so these are equal. You can see this going back to your contour. And you see that there's very little change already, and by the end it's the exact same. That is how to use Ansys-Fluent to analyze 3 different flows. Thank you.